In this video, we're going to work through some examples of hyperbolic trigonometric derivatives. So we'll get started here with the first one. If we want to take the derivative, it's y prime. We're going to work from the outside in using the chain rule. So the outside function here is the hyperbolic sine. So the derivative of hyperbolic sine is hyperbolic cosine. And we keep the argument the same. We're going to multiply that then by the derivative of that argument. So the derivative of the 1 minus x squared now is negative 2x when we bring down the 2. And if we go ahead and simplify, then we get negative 2x hyperbolic cosine of 1 minus x squared. Next example, we have hyperbolic cosine in here of 2x. We have a constant in front, so when we go ahead and take the derivative then, the derivative of p is a function of r. We're going to keep the constant, 1 over 4. The derivative of hyperbolic cosine is hyperbolic sine, no negative. Argument stays the same. Multiplied by the derivative of the argument, or the part that was in brackets there, and the derivative of 2x is 2. Minus the derivative of x over 2, well really that's just x multiplied by a half, so the derivative is just a half. And simplifying, 2 times a quarter is a half, so we get a half hyperbolic sine of 2x minus a half. In this example then, we have a natural log of a hyperbolic tangent of x over 2. So again, chain rule. Outside in, whereas order of operations we think of as inside out, so it's the opposite. So the outside function here is the natural log. Derivative of natural log, we should know, is 1 over whatever is in the brackets, so that stays the same. Hyperbolic tan of x over 2 multiplied by the derivative of that part in brackets. So the derivative of tan h of x over 2 is secant h squared, hyperbolic secant of x over 2, and that gets multiplied by the derivative of x over 2, which is a half. Simplifying it gives us hyperbolic secant squared of x over 2 all over 2 hyperbolic tangent of x over 2. We have 3 more examples here. Arctan of the hyperbolic sine of 3t. It's just practice in using your chain rule and each of your trig rules in the correct orders. So outside to inside. Arctan is 1 over 1 plus whatever comes after it, all squared. So this is, in this case, hyperbolic sine of 3t times the derivative of that, which was this part here in brackets. So the derivative of hyperbolic sine is hyperbolic cosine. Argument stays the same. Times the derivative of that part there, that didn't change. So the derivative of 3t is 3. And we write it a little neater. 3 hyperbolic cosine of 3t all over 1 plus hyperbolic sine squared of 3t. So keep in mind for these examples, we're just changing one piece at a time, remembering the chain rule. One thing changes, other things stay the same. So for this next example then, we have a product here. This is the first one that we've seen that we're multiplying the 2x to the 5 times the hyperbolic cosine of e to the x. So we use the product rule. Derivative of the first is 10x to the 4. Keep the second the same. So that's the hyperbolic cosine function. Plus, keep the first, so we'll keep the 2x to the 5 and take the derivative of the hyperbolic cosine, which is hyperbolic sine, and the part in brackets stays the same, times the derivative of the part in brackets, and here the derivative of e to the x is e to the x again. And we'll just rewrite that. Not a lot we can do here, so we'll just move the e to the x over with the 2. And everything else stays the same. And this final example we'll do in this video, this example has a quotient in it. We're dividing hyperbolic sine of 2x by t plus 2. And that automatically is a problem because we have two variables. The question is not written intended that way, so let's change that t to an x. Now we take the derivative with respect to x. The derivative then, with the quotient rule, we take the derivative of sine h of 2x, which is cosine h of 2x, times the derivative of 2x, which is 2. So there's the derivative of the top. We keep the bottom, minus the derivative of the bottom. So the derivative of x plus 2 is 1. And we keep the top. So that's sine h of 2x. And all of that needs to be divided by the denominator, x plus 2, all squared. And a little rewriting to make it easier to see. We'll keep the x plus 2 in brackets in the front. 2 hyperbolic cosine of 2x minus hyperbolic sine of 2x all over x plus 2 squared. And so there's 6 examples of hyperbolic trig derivatives. Hopefully they'll help you understand your problems a little bit better.